Okay, so this problem says a marble rolls off a tabletop 1 meter high and hits the floor at a point 3 meters away from the table's edge in the horizontal direction. How long is the marble in the air, and what is the speed of the marble when it leaves the table's edge? What is its speed when it hits the floor? Okay, so this is a two-dimensional problem. So again, one of the things you'll learn in physics is while solving problems, you want good diagrams. So here's the marble. And again, in all these problems, well, you'll need to draw an axis, and okay, so I'll draw it right there. Our x-axis will point that way, and the origin will depend on the convenience. Okay, so for this problem, we'll probably have the origin there, and so on. Now, let me see how much your intuition works. Okay, so let's say, so this, you shot the marble like that. There is the initial velocity, and the initial velocity, as you can see, only has the x component, has only an x component, and no y component. Now, let me ask you this. The time it spends in air, does it depend on how fast it was launched? No. See, the time it spent only depends on how far it had to travel in the y direction. And that depends on a y component of the velocity. If there was a y component in that direction, it would spend less time. If there was a y component in that direction, it would spend more time. Okay. All right, so that's good. You guys understood that. All right. So how long is the marble in air? So you know that it's not related to the x motion, it's related to the y motion. So we'll use that fact. Okay, so now before you guys start problems like this, what you want to do is you want to write the initial velocity in vector form, and you also want to write your acceleration. So this guy is moving only under the influence of gravity, and you want to write acceleration in vector form. Okay. Anybody want to help me out with that? What is the GJ? Okay. And G is 9.8 meters per second squared. All right, so just let's look at the y motion, and y minus y naught equal to v naught y t plus 1/2 ay t squared. Okay. So in our problem, we'll okay, I guess I'll draw it here. And there is our axis. Okay. So y naught is, they give us, this is 1 meter, and this is 3 meters. Okay. So y is 0 minus 1 meter. This is 0 minus 1/2 g t squared. So t square is 2 divided by g. And this works out to okay, so the marble hits the floor 0.45 seconds later. Okay. What is the speed of the marble when it leaves the table? Okay, so we want to find, what we're trying to find is v naught. Okay. And since we want that, let's look at the x motion, x component of the motion. So x minus x naught is equal to v naught x t plus 1/2 ax t squared. Okay. Again, here's the final exposition. Here's the initial exposition. Initial exposition is 0. Final exposition is 3 meters. Ax is 0. X component of the acceleration is 0. Okay, and so on. And here is the x component of the velocity. So we're going to put all that information here. V naught t plus, and this is 0. So okay, 3 equal to v naught, and t is, we know that it lands there 0.45 seconds later. So v naught will work out to be so that's the speed at which it took off. Okay. And then see what is the speed when it hits the floor. So see, what we want is the speed is final x component of the velocity square times that. Okay, so we need to find Vx is v naught plus axt, and that was 0. So okay, Vx, the final x component of the velocity, is initial x component of the velocity, which is 6.7 meters per second. You see, since the acceleration in that direction was 0, the x component of the velocity did not change, and we keep saying that. Okay. Okay. This initial y component of the velocity was 0, and ay is minus 9.8 meters per second squared times 0.45 seconds. So final speed is okay, so it hits the floor at 8 meters per second. All right, any questions before we close this problem? Whoa.